Okay, here's a resistor example, and I kind of walk you through, we already talked about all the theory of everything, so let's just look at an actual example of how we're going to approach this, because what we want to do is we want to be able to find the current in each one of these resistors. We want to be able to find the power in each resistor. We want to show that the total power delivered by the battery is equal to the power, is the sum of all those powers. So what you're going to do is you're almost always going to find the effective resistance of the system. And again, so let's look at this parallel branch here. Okay, so this parallel branch, these are two things in parallel. So what's the resistance of that piece of the circuit? Well, we know that how resistors add in parallel, we do 1 over R equals 1 over 4 plus 1 over 12. Well, 1/4 plus 1/12 is 1/3. So 1 over R equals 1/3, which means that R equals 3 ohms. So this effectively is a 3 ohm resistor. Okay? And so then we have to think, well, what's the system? Well, the system's a battery and a resistor and an effective resistor of 3 ohms. Well, how do these two resistors add? Well, those two resistors add in parallel. So the total resistance of our system is that 6 ohm one plus this parallel branch, which we've decided is 3 ohms. And so then the total resistance is 9 ohms. Okay, and then kind of think about how this will all work. If we know then that V equals IR based on Ohm's law, and we know the total voltage is 36, what's the total current? If the total resistance of this system is 9 ohms, well then we get a current of 4 amps. Okay, so now we know the total current. And then we look up here and you're like, well, what is the total current? Now remember, the total current is how much the battery is producing, 4 amps. Now, how many of those amps go through this 6 ohm resistor? Well, all of them. All of the current, the current produced by the battery is 4 amps, and all of that goes through this guy. And then some of it will go this way, and some of it will go this way. And so some will go through the 4 ohm, and some will go through the 12 ohm, and then at this junction, they'll join back up and become right back to 4 amps and then go through the battery. Okay? So the key here is that the total current is this particular current. So if we look at that and we do another V equals IR for that top resistor, we can figure out its voltage. And so if we know it's getting 4 amps and it's 6 ohms, then we know that there must be a 20 volt difference. So then we know that then this is 24 volts. Okay, so the battery has a gain of 36 volts and a loss of 24 volts. So what does that tell us? Well, how many volts are left to go from here to here? And again, these two things are in parallel, so they have the same voltage. Okay, the same voltage here and here. So this has to be 12, and this has to be 12. And so you can do another V equals IR relationship and say that if I know this is 12 ohms, what's the current if it's a 4 ohm resistor? And you're like, okay, well that current then is 3 amps. And I can do a different V equals IR for the right side of the branch. I still know this is 12 volts, so 12 equals I times 12 ohms, which gives a current of 1 amp. This, again, we can show then that 4 amps are flowing here, and then what happens at this junction? Well, 4 amps come in, and then 3 amps go this way, and 1 amp goes that way, and hopefully that makes sense that, look, this is 3 times the resistance, so it's going to get 1/3 of the current relative to the other one. Again, this is going to get 1 amp, and this is going to get 3 amps because they're the same voltage, and so the current is inversely proportional to the resistance. The bigger the resistance, the less current. So then we get 1 amp going this way, or 3 amps going this way, and 1 amp coming over here. And again, we knew that the voltage drop has to be the current times the resistance. So 12 volt drop here and 12 volt drop here. So it doesn't matter how you go around this loop. Gain of 36 volts, loss of 24 volts, and you can either go loss of 12, or you can get 24 and then lose 12 this way. Either way, I now know the total current, the current through this one, the current through this one, the current through this one. I know the voltage drop here, here, and here. I pretty much know everything. And then I could look at the power. The power is IV for each one of these things, or you could do I squared R. It's not going to matter. Okay, so let's look at the power of this top guy. The power of the top is going to be I, 4 amps, times the voltage of 24. Okay, 4 times 24 is what, 96? 96 watts. And again, that's joules per second. It's how much energy it's using per second. So that's the power of that first one. The power of this guy, doing its I, 3 amps, times its voltage of 12, gets 36 watts. This power over here is 1 amp times 12 volts, and it only gets 12 watts. And then what's the total? So we get 96 watts plus 36 watts plus 12 watts. So the total power of this system, power total, oh, that's a lot of math for me to do right now. So that's what, 108, 96 and 12 is 108, and then 6 is 114, so 144. I sure hope it's 144 watts. And then I want to show you that if we actually just look at the total, because what did we say? What did we say the total resistance was? That's this 9. And so then the power of the system really could just be then the current of the system. Oh, we can do this a variety of ways. We can do the total current, which we know was 4, and we know the total voltage was 36. 4 times 36 is 144. Or we could have done it in any of these ways. IV, I squared R, V squared over R. And I just want to show you that just looking at the total, we can take the total current times the total voltage and get 144 watts. Or we can individually add up the power used by each one of the light bulbs themselves to get the total power. Okay, so this is kind of your classic resistor example that shows the breakdown and kind of the flow of things. What you're going to do is you're almost always going to find this first, find the effective resistance of the whole system, which allowed us to then find the total current of the system. Then we could figure out different voltages, and what we did here is that we knew that the total current was this current, so we found its voltage. And then once you know these two voltages, you know these two voltages, and then you could find their currents. Okay, so this is kind of the resistor example.